Hi everyone. In the given problem statement, we are going to solve populating next pointer nodes in each node 2. So we are going to given our tree structure, but only thing that is different out here, it is going to have our node next pointer available. So we're going to populate each next pointer to a point to its next right node. If there are no next right node, the next pointer should be set to null. Initially, all the pointers are set to null. This is a very important point because the default condition of all of these values are null. So let me take this tree 1, 2, 3, 4, 5, and here we are going to have 7. And there is also one more problem, which is populating next pointer in each node 1, which is I think 116 problem. The algorithm that I'm going to show, the same code, exactly same code is going to solve the previous problem too. Now, the problem looks very complicated at first, but if you try to understand it, it's pretty straightforward. So here, right, initially all the values are null. Five is also null, and 4 is also initially null. 2 is also null. So one way would be just going for a depth first search, and then from 2 right we have to go to the other root node and check whether 3 exists or not. That is going to be a lot of complication. We can solve this problem using BFS or breadth first search. So the first thing that we are going to do, we are going to traverse our root node. So we are going to have a stack or DQ, which is initially going to be empty, and as of now we are going to have one value out here. We are going to check the length. So initially the length would be the 1. Now we are going to get 2. What are the children of 1? So first I'm going to pop the element out, and once I pop it out, what are the two elements that are present, which is going to be 2 and 3. Now I have taken, let's say I can do one previous. Okay, so previous initially is going to be none, and let's say I am traversing the entire 2 and 3. So let's say if I write the code, how it's going to look. Okay, so the first condition, as you are already aware, so if not root, then return none. Else we can create a stack, or let's say for this case, right, let me use a DQ. So DQ, if you know, right, so in normal queue or normal stack, right, you can just remove element from the last value, but DQ you can pop the elements from the left side also and right side also. So we are going to give it a value of root initially. Once I have done that, I am going to write a while loop while our DQ has some value. So while Q, then I am going to take few more values, length, which is going to be the current length of the DQ. So length of Q, and we are going to have one more value, which is the previous value. Initially previous is going to be none or null in that case. Now I am going to write a for loop. So for underscore in 0 to L, and here I am going to do if the previous value exists, In that case, what we are going to do, previous value dot next is going to be our current node value, and this is important. And then once that is been passed, our previous value is going to be our current value. And there are two more things, let me add it here, which is basically in case left tree exists. So if cur dot left exist, then q dot append cur dot left, and similarly if cur dot right exist, let me add it here, q dot append. When I'm going to write the code, it's going to be a little bit better. So cur dot right. So if I do the pseudo code right, initially our dq is going to have the value of 1. Okay. So now our initially the root value is 1. So, and also here one more thing I have to do, which is I forgot. We have to remove the value. So cur equal to q dot pop left. Okay. So when I'm going to the initial right length is 1 and previous value is none for the first condition. So if I'm doing it, so I'm going to pop this element. So cur value is becoming 1 or the node 1. Cur value become the node 1. So that is pretty fine for now. Okay. Now if I'm going to traverse the values, right? So does it has any previous value? So it does not have any previous value. So we are not going to do this if condition. And now our previous value is going to be 1. Okay, and this has been popped out. Now does cur have any left child? Which has left child. So we're going to add 2 out here. And does cur have any right child? It does have it. So 1 has a right child of 3. So 3 got added. Now we are going to traverse this again from 2 to 3. So 2 and 3 is going to be our values. And the first I'm going to pop out 2 from here. So current cur is going to be 2. And here, right, we're going to do, so pre-value is automatically going to be none for now. And now for the first condition, the previous value is none. So nothing got added. So this if condition does not got executed. And when I come here, the previous value going to get changed from none to 2. Does 2 have any child? Which is it does have. So 4 and 5. So 4 and 5 are going to get added, which is fine. Now we are going to loop through just the first 2 elements because we're taking the length in Q. So now the current value, right, is going to be 3. Does 3 means during this execution, does prev value is not none? It is not none. So in that case, right, we are going to execute this condition. So prev dot next is going to be cur. So what is going to do from the previous value which was null, right? Instead of null, it is going to remove this and create a pointer connection from 2 to 3. And a pointer connection got created using this function or using the code. So prev dot, let me write it down. Next is going to be cur. So it created a connection between both of them. And the function got executed and it worked fine. Now, does 3 have any more children? It does have. So the children that going to get added is going to be 7. And our loop, the for loop is going to get closed out here. And again, once the for loop is getting closed, so this value is going to become none. And now our loop, right, because 3 is also popped out, so we are going to have 4, 5 and 7 values out. So 4, 5, 7. So length is going to be 3. So we're going to loop it to 3. So initially, let me pop out 4. The current value is going to become 4. Because Brave is none right now, so nothing got changed. Does 4 have any children? It does not have, so nothing changes out here. Now, once nothing changes, but right now the previous is going to be changed from none to 4. So that's done. Now we are going to pop out 5. So our current value is going to become 5. Does, when you're looping through 5, does it has any previous value? It does have value 4. So if it does have value 4, then we are going to execute this. So 4 dot next is going to be 5. So I'm going to remove this null and a pointer connection is going to get created from 4 to 5. And now the previous value is becoming 5. 5 does not have any children, so nothing got added. Now again, the current value is shifted to 7 and 7 got popped out. Does it has any previous value? It does have any previous value. So it would be 5 dot next equal to cur, which is 7. So this value is going to get deleted and there would be a pointer connection created from 5 to 7. That's got done. And now the previous value shifted to 7. Does 7 have any children? It does not have any children. So our code is going to get done. Now all the values are popped out from our DQ. So it does not have any value. So while Q, this loop is going to get ended and we're going to return the result. So we are going to return root. So it's a pretty straightforward, simple solution using BFS. We are solving it up and I'm going to show the entire Python code for it. So it's pretty straightforward and it's very, very simple. So you don't have to do a lot more things out here. If you're understanding the basics, it's pretty simple to do. Now let us jump to the Python solution. So the first thing that we're going to do, we are going to import collection. So import collections, which is going to be required for us to create the DQ. We can also do it using stack, but let me use it for now. So only thing is that we have that pop left thing. In other case, we have to take a reference of the 0th index and then delete the 0th index, which is going to take a little bit more time. So maybe DQ helps us in this case. So in case if it's not root, right? So in that case, we can return none, or we can return anything. It does not matter. So we are going to create a queue, which is going to be collection. You can also use a stack or normal queue. That's up to you. It's a very normal thing. Maybe some more operations are required. So queue dot append, and I'm going to append the root out here. Once that is done, while there are values existing in our queue, so we're going to take the length of our current queue, L equal to length of our queue. And also we are going to have a previous value, which is going to be none initially. Now we are going to write a for loop. So for underscore in range L. So the first thing we're going to do, we're going to create a variable called cur, and cur is going to be having the value of q dot pop left. So leftmost elements is going to get popped out. Now we're going to check if a previous value exists. So in that case, prev dot next is going to become our cur. So it's going to point to our cur now. Then prev equal to cur, and we're going to check if any child is there, any left child is there. So we're going to add it to our queue. So queue dot append cur dot left. Similarly, we're going to do it for the right child also. So if cur dot right exists, then q dot append cur dot write, and that is done. Now we can just return our root. I hope this works unless there are some spelling errors. A note of caution. So as you could see, the public test cases got accepted. Let me submit it up. I hope it works. And as you could see, the test case got submitted and our code runs successfully. Let me run it again. I think the efficiency, I've seen it gone to 100% once. This keeps on fluctuating, but if you look into the code, right, we are just traversing all the node once. So it's a linear time complexity, and it's like big O of n, which is pretty efficient in this type of algorithms. So that's all for this video. See you in the next one.